I need to go through this example. I'm sure some people need a bit of more clarity on these things. Okay, fine. The question says, simplify the following. So the first one says what? Cos 180 minus theta. Now, cos 180 minus theta, I understand that 180 minus theta is a full angle. But this full angle includes 180 minus a certain acute angle that we don't know about. But we leave it as an unknown. So 180 minus theta, or the whole expression is one angle, of course. So the first thing that I need to do is to find out where does this angle lie on the cos diagram. So I'll come to the cos diagram and then look for the location of 180 minus theta, which is in the second quadrant. So in the second quadrant, I know cos in the second quadrant is negative. So I'll write the negative. Since cos is negative, the other thing that I need to understand is whenever I'm reducing 180 minus theta, 180 is got from the x-axis. So this angle is extracted from the x-axis. If it's from the x-axis, then my trig ratio will be maintained. If it's cos, then I'll come and say cos there. So first thing, where does the angle lie? It lies in the second quadrant. In the second quadrant, is cos negative or positive? Cos is negative in the second quadrant. Fine. Where is the special angle extracted from? Is it from the x or y axis? It's from the x-axis. If it's from the x-axis or along the x-axis, then my trig function or the trig ratios are maintained. My trig ratio will be maintained. So if it's a cos there, then it becomes cos there. Okay, fine. So I'll just take the acute angle, and that becomes my answer. The next question, okay, tan 180 plus theta, I know where my angle is extracted from. Where do we get this angle from on the cos diagram? This angle is got from the third quadrant. In the third quadrant, is tan positive or negative? In the third quadrant, tan is positive, so this will be positive tan. If it's positive, how about the special angle, 180? This is the special angle I'm talking about, this one. If it's 180 and it's from along the x-axis, so that means the tan will be maintained. So it will be tan what? Theta. Then your answer will be tan theta. The next one, which is C, which is sine 270 plus theta. Now, first thing again, where is this angle extracted from? Where is it? And on the cos diagram, this angle is found in the fourth quadrant. Fine. In the fourth quadrant, what happens to sine in the fourth quadrant? Sine is negative. In the fourth quadrant, sine is negative because only cos is positive in the fourth quadrant. So if sine is negative, then I ask myself, the spatial angle is 270. 270 is the spatial angle. The spatial angle 270, is it along the x-axis or the y-axis? So I understand it's along the y-axis. If it's along the y-axis, then that means my trig ratio is not maintained. It's changed to its cofunction. What is the cofunction of sine? It's cos. What is the cofunction of cos? It's sine. So since the spatial angle is along the y-axis, then my trig ratio will be changed to cos. Okay, that will be it. That's your answer. Okay, another set of examples here. So I'm still simplifying. Look at the first situation where we have cos into theta minus 180. Now I'll look at my spatial angle, which is 180 in this case. And then, according to this spatial angle is a negative. Related to the spatial angles in the cos diagram, all the spatial angles in the cos diagram are positive. So meaning something is wrong with this special angle. What is wrong? There is a negative sign on the special angle. So what do I need to do? Is to take out the negative angle such that my special angle remains positive, like other special angles in the cast diagram. So what do? I need to factor out the negative. So I'll come and factor out the negative. That is 180 becomes positive now, and theta becomes negative. And then I'll have something like that. Now from there, I have a negative, which I factored out, which implies my angle is a negative angle. So since it's a negative, dealing with cos, how do I get rid of a negative? Because I can't solve this having a negative on the angle. So I need to get rid of the negative. What do? What does cos do to the negative? Cos will make the negative to disappear. How? This means that is, as though the negative is not there, this becomes cos 180 minus theta. The next step is to ask myself, where does this angle lie on the cast diagram? So I'll come to the cast diagram and find where 180 minus theta lies. It lies in the second quadrant. So I'll take from the second quadrant what is positive, sine is positive, therefore cos becomes negative. So since cos is negative and it's 180 from the x-axis, that means my trig ratio is maintained. So if it's cos, it becomes cos. Then it becomes minus cos theta. Right. Coming to this, I'll look at my spatial angle, which is 360. Is it positive or negative? If it's a negative, and all the spatial angles are positive, so always make sure that your spatial angle is positive. If it's a negative, then that means this whole angle is a negative. How? Pull out a negative, extract out a negative, or factor out a negative. So how do I factor out a negative? I'll come and say tan, open brackets, then I factor out a negative, write a negative first, open brackets. If there is a negative there, then that means this becomes a positive, so it becomes 360. Then the theta becomes a negative. Something like that. Then, since this is tan, what does tan do to the negative? Because this is a negative angle. Whenever, remember, we have a negative angle, this is the same as taking the negative to the front. So it becomes negative tan theta. The same applies to sine. If you have sine negative theta, the negative will shift to the front and becomes minus sine theta. But if it's a cos with a negative angle, then cos is maintained as a positive. So we're going to use that here. We're applying that here to say if it's a negative, since it's tan, it will be shifted to the front, becomes negative tan 360 minus theta. Next thing to ask myself, where does this angle lie? Where does this angle lie? It lies in the fourth quadrant. And in the fourth quadrant, only cos is positive, but tan is negative. Now look at this. Tan is negative, but there is this other negative. So I'll write that other negative, open brackets, then I'll say this is negative tan. From the angle, the negative, this negative is got from the angle. Located in the fourth quadrant, where tan is negative. So tan is negative in the fourth quadrant, and then that becomes theta there. Then having a negative times a negative, which will give you a positive tan theta. Something like that. Coming to C, which is sine theta minus 450. Right. Looking at this, still I'll apply the same thing. I know the spatial angle 450, spatial angle 450 lies there. If you add 90 to 360, you get 450. In the second continuous revolution. So look at that. This becomes sine. I need to make it a positive, so it becomes minus, open brackets, 450 minus theta first. Then the negative. How does sine affect the negative? Sine will move the negative to the front, like there. So sine negative 3 becomes minus sine 450 minus theta. Is that okay? So the next thing to ask myself, where does this angle lie? My angle lies in the second quadrant. In the second quadrant, okay. What happens to sine in the second quadrant? The second quadrant. Now look, talking about the angle, you are not applying the negative. This negative is already there. So I was assuming I will just write it there first before doing anything. So I have my negative. Then where does my angle lie? In the second quadrant. In the second quadrant, sine positive or negative? Sine is positive in the second quadrant. So since sine is positive, that means I'll open the bracket to say sine is positive. Now, the type of angle, where is it extracted from? Is it from the y-axis or from the x-axis? It's from the y-axis. And we say if it's from the y-axis, the trig ratio is changed to its cofunction. What is the cofunction of sine? Is cos. Then theta. Then your answer will be minus cos theta. Something like that. Which is cos squared 180 minus theta. Now, if I solve everything, there are some facts that we have to look at. Look at this. If I have sine squared theta, this can also be expressed as sine theta all squared. So in other words, I put the whole trig function inside this bracket, then I square the whole thing. Okay? But if I have sine theta squared, this only applies on the angle. So it's not the same as this. These two are not equal. This is not equal to that. But this is equal to that. So this can be equal to that. Even when I have tan, for example, the power of 3 into 270 plus theta. This still is equal to tan 270 plus theta all from bracket to the power of 3. Something like this. So notice the square that is given on the trig ratio is the square that will take the whole expression to that exponent. Okay. Having said that, I need that space. I'll come here now. The first thing that I need to do is to change the position of the square. Let me change the position of the square and have it outside. So I have cos open brackets 180 minus theta, or the whole expression to the power of 2. So I've changed the position of the square and then took it outside. When I take it outside, I'll look at this expression. What I can do is to write it on the side. So I'm looking at the expression cos 180 minus theta. Okay. Now having this expression, now I can ask myself, where does this angle lie? My angle lies in the second quadrant. What happens to cos in the second quadrant? Cos becomes negative. Its cos is negative, fine. Where does the special angle extracted from? It's extracted from the x-axis. So cos is maintained and that becomes theta. So I'll come there, look at this. In place of this, I'll write that. But I'll maintain my square. So I'll have open brackets minus cos theta squared. This is the same as minus cos theta times minus cos theta. Then the negative and the negative will go because you have negative times negative. Then cos times cos definitely becomes cos squared theta. That's how we go about it. The next one is tan squared theta minus 360. So the same thing, I need to change the position of the square. How? Open the brackets. Then you have tan theta. Before I do anything in the angle 360, I'll change the position of my square first. Then my square is outside now. Now I can deal with whatever is inside. I can write it here, which is tan theta minus 360. This is what is inside. Now, dealing with this expression, then I have tan. I need to make sure my spatial angle is positive, so meaning I'll factor out the negative. Then this becomes 360 minus theta, something like that. So I'll take out the negative. Then what does tan do to the negative? Tan will take the negative to the front, so it becomes minus tan 360 minus theta. Fine. Then from here, having 360 minus theta, what happens to tan in the fourth angle, because that's where the angle lies, in the fourth angle. So I'll write the negative, because the negative is not concerned with your angle, so the negative is left out. I can put a bracket to illustrate that. Then tan is negative in the fourth quadrant, then I have that. Okay, fine. Then the next thing to do is to multiply the two. Negative times negative becomes tan theta. So I'll come and then take this, place it there, because this from our calculation is goes to tan theta. So I come say this is tan theta then to the power of 2, which is equal to what? Tan squared theta. And that's the answer. Now for this one, still the same way, I need to change the position of the power. How do I change it? I'll have this is equal to sine, open that bracket, theta minus 450, then it's outside now. So if it's outside, then I can deal with whatever is inside. On the side, or even here, you can continue like that. There will be sine, I'm dealing with sine theta minus 450. Okay, so now where does that angle lie? I don't know, but why? Because that's a negative spatial angle. It's a negative, I need to make it a positive. So I'll open that, take a negative minus 450 minus theta. Then what does sine do to the negative? Take it to the front, so it becomes minus sine, open brackets 450 minus theta, something like this. Then I ask myself, where do I find this angle? 450 minus theta lies in the first quadrant. That is 450 minus theta. 450 minus theta lies in the first quadrant. If it's in the first quadrant, then I know in the first quadrant, sine is what? Sine is positive. First quadrant, all angles are positive. So sine is positive. Now, since sine is positive in the first quadrant, I'll write the negative as though it's not concerned with the angle. Open the bracket. Then I'll say sine is what? It's positive. Sine is positive. First angle, that's where we have 450 minus theta. Then, since that angle is extracted from the y-axis, not the x-axis, the y-axis changes the trig ratios to their cofunctions. So, since that is 450 and it's along the y-axis, that means sine becomes what? Cos, then theta. Then this equals to negative cos theta. So I'll take the negative cos theta, place it where we have that expression. So this is equals to open brackets minus cos theta cubed. What does cube do? Cube will leave the negative there, so it will still be negative cos cubed theta. And that is your answer right there.